Okay, proper subsets on page 6. A proper subset is a subset that has good manners. A proper subset is a subset of B, and it can't equal B. Okay, so a proper subset, A is a proper subset if it's a subset of B, and at the same time, A can't be B. So any subset, as long as it is not itself. The notation for proper subset is just the letter C. Okay, it's supposed to be a U pushed over to its side. So A is a proper subset of B. Now we have to decide whether it's a proper subset or a subset or both. And maybe it's neither. B, C, D, B, C, D are all the elements from the A, also elements of B. Yep. So it's a subset. Is A equal to B? Nope. So it's a proper subset. So we got both for this one. Does that make sense? If it's a subset but not equal to it, then it's proper. Cool. How about this one? 9, is it over there? Yep. 1, is it over there? Yep. 7? Yep. 3? Yep. 5? Yep. Everything's accounted for. So all sets are subsets of themselves. Is this a proper subset? Since it's itself, it is not proper, it is only a subset. So far, so good? Let's see if everything's taken care of. Is -1 over here? Nope. So this is not a subset, and therefore can't be a proper subset. So it's neither. Anybody have any questions on how that works? Set A is a subset of B if there's no elements of, set A is a subset of B if there are no elements of A that are not also elements of B. This is strange. That's a strange definition just to say the empty set is a subset of any set you can think of. It's always going to be a subset. It's a subset that contains 0 elements or 0 terms. Let's fill in the blanks. The empty set is a subset of every set. The empty set is a blank of every set except for itself. You guys think of the phrase that goes in there? So when we compare the empty set to itself, it can't be this anymore because it's itself. Proper. It can't be a proper subset. So the empty set is a proper subset of every other set, except for it can't be a proper subset of itself. As soon as we get through all this terminology, these problems really aren't that complicated. Hence, every set except for the empty set has at least 2 subsets, itself and the empty set. Okay? Let's list all the possible subsets of the set that contains 1, 2, and 3. So I like to do it systematically. I'm first going to list the subsets that have 3 elements in them. So, what's a subset of the set 1, 2, 3 that has 3 elements? itself. Now let's list all the subsets. Are there any others that have 3? No. You can put them in different order, but they're still the same. Okay, so only one subset's going to have 3 terms. How about list all the subsets that have 2 terms or 2 elements? Michaela, what would one of the subsets be that has 2 elements in it? 1, 2? What's another one, Josh? 2, 3. Are there any more? What's another one, Allison? 1, 3. Are there any more? 1, 2, 1, 3. 2, 3. And then if you rearrange the order, you're just talking about them again, so no others that won't be repeats. Now let's list all the subsets that have 1 element in them. The set that contains 1, the set that contains 2, and the set that contains 3. So listing all of the subsets, I do it systematically. Are there any other subsets that you can think of that belong here? How about the subset with 0 elements? And what would that subset be? The empty set. It's the easiest one for us to remember, but every set has a subset that is empty. The empty set. Okay? Is that okay? This one up top is just a subset. These down below, not only are they subsets, but they have another category called proper subsets. So there are some, properties of subsets later on down the road that we don't want to include itself as a subset. So we refer to those as proper subsets. We just want to study these. Anybody have any questions about that? We'll pick up where we left it off right there. Tomorrow, we'll talk about some more subsets.